Hello and welcome to the Homeland Defense and Security Information Analysis Center webinar covering CBRN Survivability. My name is Steve Rutherford and I'm the director of the HDIAC, and we have the privilege of hosting Mr. Mark Diglio for today's presentation. I'm also grateful to everyone who is taking time out to join us during these challenging times. I'd also like to thank our sponsor, the Defense Technical Information Center. The HDIAC mission is to collect, synthesize, produce, and disseminate scientific and technical information to the DoD and federal government users, and this webinar is made possible through DTIC sponsorship. So I've got a few housekeeping notes for you as we start out. Note that all the lines have been muted, so if you have questions during this webinar, please submit them using the attendee chat box on the left-hand side of the screen. And we're going to work to save the last 10 minutes or so of our hour today to go over those questions and discuss them. If we run out of time, we'll make note of all remaining questions and post responses after the conclusion of the brief. Please also note that this webinar is being recorded, and a link for that recording as well as the slides will be available at our website, www.hdIAC.org, for later download. And with that, it's my pleasure to introduce to you today's presenter, Mr. Mark Diglio. Mr. Diglio is the U.S. Army CBRN Survivability Program Manager, where it is his job to ensure the U.S. Army's ability to fight, survive, and win in CBRN environments. He works initiatives at the Army, Joint, DoD, and international levels to increase CBRN mission critical survival for the U.S. and its allies. He does this through educating capability and material developers, informing senior leaders, and managing efforts to improve CBRN survivability, requirements development, criteria, and CBRN survivability policy. Along these lines, Mark has authored several journal articles on chemical defense and CBRN survivability. Mr. Diglio holds a Bachelor of Science degree in Chemical Engineering from the Pennsylvania State University, a Master of Business Administration from the Florida Institute of Technology, and a Master of Science in Defense Strategic Studies, Weapons of Mass Destruction from the Missouri State University via the National Defense University Program. And it is our distinct pleasure today to host Mr. Diglio. With that, the floor is yours, Mark.
Okay, well, thank you very much, HDIAC, for hosting this, and Steve for that great introduction. So whatever I say is not an official DoD position, it's just my opinion. I'll qualify with that to start with, especially since this is being taped. But being at the unclassified level, I'm going to try to speak to references, but not direct numbers and such. If you need them, then please just email me and say you'd like the references, and that way I can make sure you're somebody that can get the list of all the references, some of which are confidential. But with the numbers and names, you'll be able to look them up, or should be able to obtain. All right, so here's the pretty graphic. It shows the Army and a mushroom-shaped cloud. I work at Corps Headquarters, Department of Army at the G357, which is Operations, Plans, and Policy. And I'm with the U.S. Army Nuclear and CWMD Agency that's combating weapons of mass, or countering weapons of mass destruction, and changed. That became an program. Okay, so let me try to speak a little clearer here. Maybe you can hear me better. I apologize if it winks out from time to time. Okay, my contact information's on this first slide, so if you need to reach me, use the email address or the phone number. YASENCA, we do a lot in terms of assisting the combatant commands in preparedness for what happens if things go hot in terms of nuclear, chemical, even radiological. So without delay, we'll get into the actual briefing here. Bang. So the agenda, I hope to touch on threat. The unclassified screeners gutted a fair number of slides, maybe half dozen in terms of references to documents and countries. But beyond that, I think we should be ready to go, and I can pretty well speak off the cuff to a lot of the concepts and things that should help everyone that's out there. I apologize for those of you that have seen these slides before, that are within the DoD or the Joint Staff, or even DTRA, Defense Threat Reduction Agency. There's probably a lot of this information that's not going to be new to people, but there may be some little nuggets in there. So hopefully, you all can take something home, or take something home with you for this. My deck. Okay, here we go. So this graphic is talking to world threat. Had issues back during the Cold War when Russia or the Soviets actually had gone hot with their first nuclear test. I think it was in 1949. And that ushered the Cold War era, which was pretty much the Soviets and the U.S. back and forth in an arms race with nuclear weapons and deterrence. And who knew? The good news was deterrence worked. We actually, did not have a World War III, so that was wonderful. Along comes the 1980s, and the Reagan administration was putting space wars out there, kind of like, and so trying to keep up with the U.S. financially and everything got really hard for Russia, and basically the Soviet Union, not Russia. So with that, the demise of the Soviet Union ended the First Cold War. So this is history, it's not classified. But over the next ensuing 10 years, there was kind of a peace dividend in the 90s where a lot of the free world was like, hey, we don't have to worry so much about nuclear threat anymore. So at that point, it was like, hey, we can start putting that money to plowshares. We can do other things with it. The requirement for CBRN survivability has always been there for land-based material, for Army systems, mission-critical systems. But the priority for that requirement, sustainment, maintenance, probably started to suffer a little bit with budgets getting tight or one thing or another. Then comes the 2000s. We go into, there was 9/11. We went into Iraq, and we didn't find much of any WMD at all. So again, there was this kind of notionally we didn't have an issue, but instead, in the late 2000s, there was actually our near-peer competitor was starting to try to re-grab some territory in former Soviet Republic countries. And with that, we began to realize, hey, we're going to have an issue. In addition to that, we had North Korea had done some positive tests for the first nuclear weapons. I don't know, there was a 2006 or something like that. So they're nuclear capable. So the end result is we're kind of in this Cold War II situation. Russia has always had a doctrine, not always, but since the late 80s, where of escalate to de-escalate is what we call it, which is basically for regional conflicts, they could toss a little nuclear weapons, and I guess pacing them, going to really break it if they're going to. But essentially, we're in a Cold War II era, and the threat's much higher than it used to be. When I say Cold War III on this slide, what is that? What am I referring to? I'm really referring to the space, the next domain, which, so treaties are falling to a degree, like the INF treaty, the Intermediate Nuclear Range Force, Nuclear Range Forces Treaty. And that was basically for intermediate ranged nuclear ballistic missiles. So what were nuclear missiles? So the problem is why those were important is because that ups the ante in terms of instability between, say, Europe and Russia, for example, but also on the Asian continent, places where that leads to instabilities as well. So with that, we've got kind of a lot more instability. We've got a lot more emphasis on stockpiles that are going to be looking at intermediate ranging, and all of a sudden tactical nuclear weapons may be in vogue. So with that, the priority on CBRN survivability is a lot higher within the United States, because we're going to have the chance that we're going to have to conduct mission in CBRN contaminated environments is much higher. Maybe I spilled the beans here. So outer space, we have a treaty. You know, there's not going to be any nuclear weapons or anything like that in space, but now there's some infighting or whatever. U.S. would like to have a commercialization of space because it's a huge economic boon if, companies can start marketing certain things and taking asteroids or whatever. So if the outer space treaty fails, and that's been around since, I guess, 1967 when it first started, and then maybe late 70s. I mean, it's something that's really kind of kept the world from an armed space race. If that falters, then maybe we got to have a Cold War III going too. So anyway, that's what that talk was about. Okay, WMD threat, bottom line here is that the threat's higher, and it's going to be higher in years to come. All right. Nuclear and chemical threat, why CBS? So I think I've already spoken to this one about the treaties breaking down. I think we can move on to the next slide. And again, I'm kind of beating a dead horse here. But what I wanted to speak to is DoD 3150.09, which is kind of the DoD Bible for CBRN survivability policy. In fact, that's the title of it, CBRN survivability policy. This document's been repetitively updated over the years, which it puts more emphasis and makes the requirements for new capabilities and actually services for tracking the hardening of systems in the field more arduous, more mandatory. So that's a good thing. And when we are 100% as good as we can possibly be in CBRN survivability, it can actually serve as a deterrent. So the renewed priority is there, particularly for mission essential or mission critical systems. And I'll get more into that further along in the brief. Now I'm going to get into the policy portion of the brief. Let's see. So I was talking about earlier, and you'll see kind of this transition from one part to the next, where I end talking about something, I kind of pick it up in the next section. This is one of those cases where DoD 3150.09 started back 2006, 2008, and then subsequently there have been revisions, and I'm aware that there's another one going to be coming out maybe this year, or I would expect sometime this calendar year, which again is going to add more fidelity to implementation of CBRN survivability programs within the services. Great, next slide. And I'm going to get you guys out of here early. No, I doubt it. Here we go. This is an overview, and this slide, this is one you should print out if you can, because basically it has reference to all the references that were other slides deleted or references that were erased that talk about where we go to within the Army and DoD for guidance in terms of CBRN survivability policy. But I'll try and speak to some of these in the subsequent slides for that which we know are clear for what is fully clear. this has been briefed, this particular slide, at several unclassified forms, so this should be good. If you want to access some of the classified ones and you have clearance and need to know, you're certainly welcome to have them. I believe most of these are actually unclassified. NATO by nature, most of those, particularly if we're talking about anything atomic or nuclear, you're really bumping it up to a classified level. Maybe not secret, but confidential at least. So without more delay, here's the JSID, which stands for the Joint Capabilities Integrated Document System Manual. And it's the Bible for how new capabilities are developed. So legacy systems actually have a pretty robust level of hardening with them. But we want to ensure that the future systems are doubly hardened, that they're very protective and survivable. And if you hadn't figured it out already, this brief for CBRN survivability, we're talking about material or weapon systems, platforms, mission critical systems that are in the field. This does not apply to training systems. It's not going to try to apply to planning. It's not going to peacetime type stuff. Not talking about personnel survival inside, like you got to wear protective equipment or anything like that. We're talking about material systems. But the JSIDS manual codifies, makes CBRN survivability requirements mandatory for systems, and that's how it's addressed in capabilities development system, and I'll get more in detail with that later. Before we go a lot further, I need to kind of lay out the definitions, and this is really kindergarten for CBRN survivability. But what we have here is CBRN survivability, and I'm not going to read the slide to you. But basically, that's the overall statement. It's concerned with contamination. That includes fallout. That's CBRN contamination processes, but also nuclear survivability, where you're worried about nuclear weapons effects, blast EMP, initial radiation, shock wave effects, which are very short in duration. So if for any reason you're already sheltered from that wave that comes through, that adds a lot of survivability to a vehicle, for example. So there are a lot of conditions, doctrine, procedures that can help to make assets more survivable. And that's just kind of like that's to pique your interest for later. But also hemp. So what you'll see here, I talk about CBR contamination survivability, and that is usually split into 3 different areas: hardness, decontaminability, and compatibility. And the definition speaks for itself, but it's a good reference if you ever have a question regarding what are those definitions. At least this is what we use in the Army. Okay, the JSIDS concept, I talked about the JSIDS manual. It spells it out pretty well, soup to nuts. But what's the problem with this slide? What is it that people have difficulty in following? Well, if you follow the formal process, it's not supposed to take 16 to 20 years, but it has in the past. This is designed to take maybe 10 to 12 years. And there have been other approaches now where they're trying to get this process shortened to 5 years. And I'll talk about that later in the brief. Now, milestone A, that's what MS stands for. That's really where a program begins to get kicked off, developing all the requirements and initial capabilities document for standard programs, and then capabilities development document is usually matured and approved just before milestone B decision by the guy with the checkbook, usually the milestone decision authority. And then after that, so to be honest, Once that approval happens at milestone B, it goes into engineering, manufacturing, development phase, which is full-fledged test and evaluation. Prior to that point, you're at a tech readiness level, typically much younger, with more accelerated development programs. They're taking commercial off-the-shelf systems or foreign military systems of allies, and they're saying, can we use this for a U.S. adopted version? We're going to test and evaluate it, and we're going to speed that to fielding a lot quicker. So anyway, the windows to get in CBRN survivability requirement are for the ICD to make sure the right language is in the initial document in terms of does it address threat, the proper threat scenario or environments that this system will be in, and is it, that's the main one I'm concerned about, that it actually picks up CBRN. I mean, if it's a system that's training or something that's not going to be in the main theater battlefield or something, then it probably doesn't need to have that threat mentioned in the ICD, and I'm not worried about it. But if it does, I want to make sure it gets picked up. Cyber survivability is another subject, but just out of respect to them, that's a very important window to them for risks and threat environment as well, for them to get picked up. Okay, so before milestone B, we want to make sure the right language is in there for CBRN survivability requirements, both for CBRCS, which is chemical, biological, radiological contamination survivability, and then also for electronic systems that are mission critical, that they have, oh, well, that's another one. To designate mission critical systems properly, they have to formally state in the requirements document, this is designated CBRN mission critical system, or it's not designated. And that is one that I frequently, even with systems that are, yes, I'm mission critical, they don't clearly state that in the document. And another thing is, to actually get tested and evaluated properly, capabilities development documents need to specify clearly what the requirements are for CBRN survivability. Because if they're not clearly stated, they're not going to get picked up in the test and evaluation program or the SEP, Systems Evaluation Program. So let's go on. Probably spent way too much time on this one, and get into the requirements. Okay, this was a really pretty slide that included the decision tool for determining if a system is mission critical system or not. And this was one of the latest CBRN survivability articles that I had written last year, I think it was, on mission critical system determination. But they're just basically two simple questions. Does the system perform mission critical functions? If the answer is yes, then that's got your radar up right there. Second question, does the system's mission profile operate under threat of CBRN environments? If that's a yes, okay, now you got like, that's two out of all the system, you're fired on that. Got a good chance it's going to be a mission critical system for designation, CBRN mission critical. Is it a weapon system? Well, main battle tanks, attack offensive weapons, main defense systems, those are weapon systems. Major platforms are all going to be designated mission critical systems. Does a system have electronics? If it does, that's going to tailor what requirements are a part of that mission critical designation or carried with it. So if it's a weapon system, it's going to have INWE, initial nuclear weapons effects requirements. If it has electronics, it's going to have HEMP requirements. And by the way, if it's designated a mission critical system, then it must have CBR contamination survivability. 100% of all mission critical systems need to be CBR contamination. And why do you think that is? It's pretty simple. Basically, the probability that you're going to see chemical contamination is astronomically higher, significantly higher. Okay, maybe I'm exaggerating. It's dramatically higher, in my opinion. My opinion, I'll qualify it that way, that you're going to see chemical contamination in the battlefield. And if not chemical agents, it could be, you know, just fuel oil. It could be industrial, toxic industrial chemicals or whatever. But the odds are so much higher. The consequences may be lower, but the issue is you need to deal with it. So that's why CBRCS is a part of all mission critical systems. And one other little caveat I wanted to add to this, and that is, if you're not designated CBRN mission critical system, that doesn't mean you shouldn't still have a desirable hemp protection, for example, or CBR contamination survivability. You may not have to have initial nuclear weapons. That doesn't mean, okay, I'm not going to address these in the capabilities document. But if you're designated CBRN mission critical, that comes with responsibilities. CBRN. First off, you're gonna, even when the system's fielded, it's going to be forever tracked by HDIAC. That's one for Army systems. The other is that you're going to have a maintenance program for preventive maintenance checks and services on the actual integrity of the carp or the coating. It means you're going to have a hardening maintenance or surveillance program to check that the hemp is still there as well. Electronics. And that's the end of my brief. No, I'm joking. I'll be able to run through the rest of these pretty quick. So I pretty much spoke to AR 7075 already. That is the Army survivability of personnel and material. And this slide's been presented a number of times. It just breaks it out as to 3 main areas. Spoke to it earlier. I'm not going to do it again. But what I do want to draw attention to is this bit about a waiver. What's a waiver? Well, a waiver is often confused with like a free get out of jail card. I don't have to do CBRN survivability. It's actually just the opposite. A waiver is designed, the reason it was created as an instrument for the Army systems, mission critical CBRN system, is so that if somebody partially meets or fails to meet CBRN survivability compliance requirements, don't quite make it, then the waiver package is supposed to address how they are going to make it better. Okay, how am I going to, basically, what's my plan in the .mil PF matrix? So basically, I might get to this a little bit more detail later rather than hold up on this slide. I want to finish the brief in probably another 10 or 15. But the waiver process is one we have. The Army has a CBRN Survivability Committee, and it's a body of Army SMEs, of different organizations that address their area of expertise for waiver packages. We will review the proposal for how they intend to get better. And there's a whole slew of different ways that you can meet survivability if you don't completely meet it through test and evaluation. And I'll get into that later. But the main thing here is that you have to have your equipment tested and evaluated. If you don't have the requirements, you don't get tested. If you don't get tested, we can't tell what a waiver or solution. Waiver package would be to be reviewed and approved. Yes, that's a good approach for addressing survivability in the field. The M is a small m because that's the last thing we want to ever tackle when we get into solution sets. It's the most expensive. So obviously, unless it's a real simple material change, we'll try to do it doctrinally, and I'll give you a lot of examples for that. But now I'm going to talk about requirements. This is philosophy behind CBR contamination survivability criteria. And essentially, we want to get soldiers to the lowest possible level of protective posture because that interrupts their tempo the least, or the least impact on their mission success. The other thing is it helps their health risks in terms of heat exhaustion. So the better we can have that piece of equipment not off-gas chemical agent, for example, after it's been heated, the better that our warfighter is going to be able to conduct his mission. Now, this slide is just supposed to show you what it looks like in terms of decontamination, decontaminating a vehicle. This is a Humvee. You can see that for a tank or larger vehicles, platforms, it's going to take more men to do a decon. Some of the test requirements for decontamination I'll get to now. This slide raised some eyebrows, but essentially these have been the same requirements for many, many decades and not classified. We have a very, very high challenge level that's difficult to obtain in terms of what we want our equipment to survive from contamination. Some may say that's unrealistic, but it's not. If that is the only munition that an adversary may have a lot of that they want to get rid of, or if there's territory denial, there are a lot of purposes for using tactically or possibly even strategically. It gets just so unyieldly to have strategic. But operational tactical use, particularly tactical or chemical, quite possible. We have 10 grams per meter square meter of surface. It can be done on small swatches or whatever. Of these three, of chem, bio, and rad, we're most worried about chemical because chemical absorbs into the surfaces, and even after decontamination, it can off-gas. So that the test is like we'll slime the material, we'll let it sit for an hour, and then we will take 75 minutes to clean it. However many, dependent on mission profile, will depend what the test operating procedure is for testing that major platform. And the idea is, okay, after time's up, we check for negligible risk levels that are indicated on this slide. I had another slide, which I'm going to get to, which all the data was kind of deleted. Even though this was cleared for, I believe the actual data was cleared because it's like OSHA standards. But just to be on the safe side, we deleted it from this brief. But again, anybody that asks for the brief that's DOD, that has as a contractor, I can get this brief to you. And any of the, the references or policy that are in it. Because you have a need to know, and you're working to help the security of this country, and that may further be extended, I believe, to Homeland Defense. So, but what I wanted to talk about this is CBR negligible health effect. We are trying to create new policy for operational exposure guidelines. Just going to talk concepts here. Basically, this is a situation where we do a health risk assessment on what level that concentration, what agent that equipment might be contaminated with, and then how much time went before you deconned it. It gets very technical and all that. You need to have, we're trying to simplify it for a field commander or unit commander where he can go, okay, I got this kind of detection equipment, I got this. It'd be like a menu. And with the operational exposure guidelines, a little book, flip it open, okay, we got hit with this, we got to clean it within 2 hours or 1 hour, and this is the level of off-gas or not. In the old days, I'd decon the equipment, I'd be in Mach 4, and then I'd still have to wear Mach 4. Well, not anymore. We're going to get to a point where for chemical, because detectors have gotten to that state-of-the-art level, where you can actually still use that equipment with, like, maybe mask only. Maybe you can use it without a mask for 4 hours, conduct a 4-hour mission, and then you're back and you're done. You didn't need any protective during the duration of that mission, for example, an 8-hour mission. It just depends. Or maybe the advice is going to be you got to do more decon, rinse and repeat. But anyway, that's what OEGs, you might have heard some of that discussion. There's talk about, there's a lot of interest in NATO, North Atlantic Treaty Organization, although it's not just Atlantic more. But there's a lot of interest there as well, because this just opens the aperture of increasing opportunity for mission success and decreasing risks caused by off-tempo hindrances from full PPE. Heat exhaustion not being the least of them. Okay, I've gone on to preventive maintenance checks and services. This is talking about AR 750-1, which is the Army Maintenance Program policy. And you can see there a chapter, everything has to get painted. Somebody wants to waive carc paint, don't come to me. It's not a CBRN survivability issue. You would think it would be, but there's actually 24 different properties with carc paint. We're like number 4 or 5 on the list, down on the list for CBRCS, contamination survivability. The other ones is like for, masking and really cool stuff for all this other I can't even get into. But the beauty is there's been an awful lot of research into it. There's a different type of carc paint and spec for different types of applications. So I would say that this is probably one of the best ways you can meet CBRCS is with using carc paint. And carc paint, it's mandatorily required. If you don't want to use carc paint, you only have a few of these systems. It's just for like a very specialized use or something like that. It's a commercial off-the-shelf item. You may be able to get a waiver from G4. That's the logistics folks. But you're not going to get one from G357 on CBRN survivability. So there are ways to meet CBRN survivability besides just the coating. The paint, using carc paint, that'll get you most of the way there. Most all systems in the field meet CBR contamination survivability. Sorry for that one. But if you don't have the carc paint, that's a heavy hit right there. But use a mill standard 3056. There's actually design guidance in there for systems contractors on choice of materials and design standards to follow that will help you in terms of minimizing problems from contamination still lingering. Okay, we're on to nuclear survivability, and this is not my lane of expertise. I got a lot of those guys around me, so I'm not going to say too much about it, except that for nuclear hardening, if the mission, and I can go into a little more detail, we'll see. So when they're in the same environment together, how much of the crew needs to survive for, let's say a weapon system needs to shoot, move, and communicate, how much of that system, the crew needs to survive to be able to do that, finish the mission successfully. So that's a level of protection that the tank must provide the crew because they're viewed as an overall system. So that's what that first line is really speaking to. And let's say you have a crew of 4 and you need 2 to survive to be able to shoot, move, and communicate. Then 50% would be your level. Maybe you need 2/3 or 3/4 of the crew to survive, and that, it depends on the size of crew. It depends on all the different types of how complex the activities they have to perform are. But that's what drives the criteria, and those are issued by USENCA. It's determined per system based on the mission profile and threat environment and all that stuff. But so, for example, if you are a recon helicopter or UAV or something like that, you're in the distance or you're going around, you're not in the main thick of things, you're not in ground zero for an armored brigade or something like that. Your criteria probably for nuclear are going to be far less. Tank's going to be pretty heavy. This next slide is nuclear effects. Just to be a demonstration, it's basically downtown anywhere. So I try to delete any kind of identifying information with it. If you find some, wonderful, but it's just meant to be I really don't know what values are. It's just meant to be conveying an image in terms of what happens when a nuclear weapon goes off. There's fallout. That's at different levels of radiation that contaminate the ground, that troops are going to have to avoid for a period of time, whether it's a half hour, an hour, 8 hours, or a few days, or whatever it is, depends on the size of the weapon, the type of the weapon, the height of burst, all kinds of other factors go into it. But that's the kind of modeling that USENCA does, and that's the kind of thing that feeds the criteria that are developed for systems, for mission-critical systems. Here's another one that the cleared for public release reviewer decided, let's just delete these and play it safe. So that's okay with me. I mean, I can talk to these. CBRN Contamination Survivability, USENCA also issues the criteria for CBRN Survivability test protocols. Dugway, I'll put a plug in for them, ATEC and Dugway, they have this reference as well, and they use it religiously. It's from 2005, I think it's 30 May, and basically it leaves a lot open in terms of flexibility. I kind of just referred to that earlier. You can use how many men depending on mission profile, and the document allows that kind of flexibility. So U.S. documentation, let's see what else is there. So we got like AR 7075 speaks to requiring these, or says, hey, you've got to have these requirements in your systems for survivability. ABCA, now that is APTA, or I think it's like Australia, Britain, Canada, America. I think they added new, so America, Britain, Canada, Australia, and New Zealand. Afghans as well. But that one is probably not as strong a contender. A lot of these documents, it's being revived now as the threat from foreign adversaries has been on the rise, both near-peer competitors in the U.S. and rogue states. So those documents are kind of getting all polished up again. NATO documentation, there I think is AEP7 that kind of lists almost, I'm not going to say chapter and verse, but talks to the same things that the USENCA criteria speak to for CBRNCS. Now, for nuclear, you got HEMP. That's MIL standard 2169. C, there's a new version that'll be coming out probably this year, maybe, which will be a D version, I think. But that's the waveform of energy spike. There's a lot of details about hemp I'm not going to go into, but I just want to say that hemp is high altitude electromagnetic pulse, is a high energy spike in terms of nanoseconds. The shorter period of time that energy is collected and massed, the more potent the electronic or whatever electrical formulas, but basically it's a lot more potent in terms of frying circuitry and systems, particularly if you have any collectors like unshielded power cords for communications, like for headsets. There's a fair amount of protection already with a lot of commercial off-the-shelf systems, but it may need an extra bump, and there are ways to get that. You can contact me or some of the experts here at USENCA, and we can help you with some advice on how to do that for designers or for equipment that's already commercial off-the-shelf, and you're looking for ways to get it to the field. The most important thing, I'll put this plug in again, is to get it tested and evaluated. NATO document, you have, I think it's AP4 is what you want to look at for nuclear effects, for INWE, which is there. You see it's blast, thermal, initial nuclear source region, EMP. Oh, I'm fading bad again. I'm sorry. I apologize to everyone. I'm going to try to get my head faced right into the microphone. Can you hear me now? Can you hear me now? Okay. This next one is nuclear hardness program, very similar to the PMCS, except this one is for hemp protection to make sure that the EMI shielded gasketing, the gaskets for seals around doors and ports, EMI shielded cabling, that it's got like just a metal, a Faraday cage is like a bird cage with a lot of tight wiring in there. It basically acts as a pulse shield for this wavelengths and absorbs the power and grounds it. So that's kind of the concept of shielding. If you have to shield, it can get expensive in terms of filtered ports, plates that would absorb anything that helps to protect the actual computer circuits from frying. That's what we're after with that program. But this would be done probably most likely at depot maintenance, again, on a periodic basis, annually or every other annual. It doesn't have to be every vehicle. But the idea is if you have retrofits to that vehicle where you're puncturing, drilling holes into the armor plating, or you're adding extra cabling and all that, that is going to interfere with the test results for hemp that were done. Most likely, another plug for ATEC out at White Sands Missile Range and the Survivability Vulnerability Assessment Directorate. So you're going to have to actually have that part reassessed. So that's what the HMHS is about. Okay. Let's see, I skipped one. Yeah. Okay. So now we're on the final conclusive part of the brief. This is about concerns. I just want to say why, again, emphasize CBRN survivability, why it's important on equipment. So you're looking at for contamination survivability, for hemp, for electronics, and the thing about hemp, that pulse can happen way far away, like a state away, or the other side of the country. And if you don't have hemp protection, your happy day is going to be a real bad day. And it's like, hey, man, I wasn't even in the thick of it. I wasn't in the blast radius or anything. Well, hemp doesn't discriminate. And that's why for military systems, even if you're not mission critical, considering adding a high altitude electromagnetic pulse requirement. Not real expensive to get tested, maybe $10,000 or less if you are riding with a major system that's being tested at the same time concurrently. They can test, I think they had one situation last summer where they tested a couple of dozen smaller handheld systems all together. So there are lots of ways to defray costs for commercial off-the-shelf systems for hemp testing. Do not be afraid to include this requirement. It is not a showstopper, and it's something that can be addressed, I think, easily enough. And without INWE, okay, that's self-explanatory. That was a heavy-hitting slide. CBRNS, more on the same. Next, we're talking about in the capabilities document, there are things called mandatory requirements and optional. So when you are a designated CBRN mission critical system, those CBRN survivability requirements need to be in the mandatory section, not the optional section. I think this slide kind of speaks to itself, but that's in JSIDs. Real quick, I'm going to get into the JSIDs again. You can see those windows. I spoke to this earlier. I'm not going to speak to it any further now. Next comes mid-tier acquisition. I really showed you this just to see what the 10-year, there we go, I'm lost. It's just a little lag here for slide control. So this one, basically that's, let's say that's the 10 or 12-year mix. We want to do it in half the time. Then we go to a thing called, or a third of the time, we go to mid-tier acquisition. Now, this just talks about how that was approved by Congress over 2016 to 2018, and it allows an opportunity to cut the red tape. But believe me, it's not really cutting red tape. There's a lot of other red tape that comes with MTA, has a lot of extra stringers with it. But it does allow somebody to get through the process acquisition more quickly, particularly if they have off-the-shelf systems that are really a huge technological leap. And that's what we're looking forward to, getting systems done in 5 years. So you see two different scenarios here. One is called rapid prototyping and the other is called rapid fielding. So Army Futures Command deals with the Army's major new developments. And of their 31 plus programs, and I'm going to say plus how many, but I believe practically all of them fall into the rapid prototyping group, except for maybe 2 or 3 that fall into the rapid fielding, meaning, man, this thing's already tech readiness level 9. So on a scale from 1 to 9, this is already, we know it works and want it in the field right away. So that can be done real quick. But for most systems, you're going to be back to the 5-year. And guess what? 5-year can slide into 10 years. So there are other windows. Either you do it incrementally for different, we're going to get an initial capability out there real quick and then do other increments, or hey, we tried and tested and all the stuff that was available didn't work as good as we needed it to, and we're going to have to go back and redo, relook the drawing board. But again, the idea is still to get this stuff to the field quicker and the latest, greatest, rather than fielding outdated technology with, I don't know if any of you remember 236s or 386s, I guess, 486, 586, the old computers. Now we're back in those were the Stone Ages, so that's the type of equipment we were fielding. That's not going to happen, hopefully, knock on wood. Okay, so typical prototype timeline. Here are the timelines for MTA. The mission critical system concerns with MTA, as you can see, and I'm going to flick back one more slide. You can see 5 years is not a lot of time. If you aren't deaf, if you aren't locked on getting CBRN survivability requirements in the program and in the test and evaluation program, guess what? You're going to get to that decision milestone to field, and the question's going to be asked, did you address CBRN survivability, particularly for mission critical systems? And if the answer is no, that could be a guffaw. That could be a hold up, or it's going to be an awful lot of money to be spent, because when changes are done, when you bake in CBRN survivability, if they can design it in or at least test and evaluate it to get our arms around what is the problem and what kind of solution, that's where we are. It's so much better than trying to bolt on solutions later. And the solutions later was the .mil PF situation. So I want to apologize for kind of being redundant on a lot of stuff or fading in and out. These are the takeaways. The threat's a lot higher now. There's a lot more emphasis on the need to be ready and have material survivable with protections, and vital especially for mission critical systems. Okay, that concludes my brief.
Mark, that's great. Thank you very much for that very detailed brief. It was we're very glad to have had you today, and again, thanks for taking time out to prepare and give this brief to our audience. So we have a couple questions. One of them, our first one, is from Dr. Roberge, and he has obviously biological weapons on his mind, I think as many of us do. And his first question is, what kind of protection systems are used for biological weapons? And then he asked about filters that have been developed or enhanced to prevent pathogens from entering things such as armored vehicles.
Okay, well, that was my former life. I was the leading CBR filtration expert from 1980 to 92. So yes, right. But basically, it's a HEPA filter, high efficiency particulate absorber. As I recall, we're really going back here, right? But I believe it was like certain microns, 0.1 to 0.5 is the most challenging area for absorption. If it's less than 0.1, then you're talking about those particles are going to be easily absorbed by a static charge, or electric charge is going to trap those in the filter. The question, what was the question? How are systems protected? combat systems, if they're collectively protected, then they will have a HEPA filter for CoPro or powered respirators. If they don't, then they're going to be wearing a gas mask. The gas mask has a HEPA filter with it as well. Okay, next question.
And then he asked about the addition of UVC, which is something that's been, we in the HDIAC have been asked many questions about this, including UVC systems into ventilations to help kill pathogens like is done in airports and major office buildings and that sort of thing.
Okay, well, you're really getting into survival of personnel, which is not CBRN survivability. I think I mentioned that earlier in this brief. We do have experts for bio here at USENCA, but that's not my lane of expertise. As far as using UV to kill bio, there are certain types of bio that are very susceptible to, they could work. People used to say, hey, use plasma discharge for decon of chemicals to break them down and everything, but there are a lot of toxic byproducts created with plasma discharge, very high temps. Okay, next question, sorry.
So, Dr. Roberge, I'll chime in on that. Mr. Diglio's responsibility at the Army and for the joint systems, I will tell you that the Navy and the major air handling systems and ships, we answered a technical inquiry not too long ago where the Navy was actually considering doing something like that because of the way the air handling systems are set up. So moving on to the next question from Mr. Dennis DeMaio. He says, CARC paint is not typically a catch-all against all chemical warfare agents. There are still absorption issues that make decontamination difficult. So he goes on, and what he wants to know are there any advances in CARC technology that you're aware of that will provide protection against all of the common chemical warfare agents?
I would want to say yes, and I'm not the CARC expert. I would refer you to a gentleman called John S. Carcega, and he manages the Army's CARC program. And one of the principal investigators is Dr. Stephen Mantooth out of Edgewood. Just forward me your information, I'll forward it to you, but I believe the answer to that one is yes, particularly if we're talking about the 3 recent additions that were former 4th generation agents that have been added to the mix. But yes, I believe so. And there's been an awful lot of recent advances in CARC in the last 5 years in CARC testing and research.
Yeah, and Dennis, I would chime in on Dr. Brent Mantooth as well. We're actually working with him right now on a core analysis task to discuss contamination mitigation. Again, Mark has offered to put you in touch with them, and we can do that as well.
Oh, and I did want to say, he's also right. If I may, just for real quick, he is correct. CARC is not a catch-all. When I'm nervous, I say things that aren't, words matter. He's absolutely right. It's not a catch-all. There are a lot of fundamental design practices that are very important in assuring that you don't trap contamination, particularly bio. Of the bio agents, anthrax is the worst actor in terms of difficulty in trying to decontaminate or make sure that the item's clean, because anthrax has a very high survival rate in spore form. I can't say that's true of necessarily most of the other biowarfare agents, but that would be the end of my addition to that. But yes, he's correct. CARC is not a catch-all for CBR contamination.
Great. Thanks, Mark. I think that takes us right up to the hour, everyone. Thanks so much for joining us today. As I mentioned at the beginning of the webinar today, the slides and recording of this presentation will be made available for download at our website, www.hdIAC.org, as well as all the other webinars that we've presented are there and available for your download, as well as our podcast series. If you're interested in learning more about the HDIAC or in getting involved as a subject matter expert, presenter, or expanding your presence in the user community, please feel free to reach out directly using the contact information that we're going to post on the left-hand side of the screen. In addition to these monthly webinars, the HDIAC also offers monthly podcasts that span the range of our 8 technical focus areas. We also put out a bi-weekly email digest that you can sign up for, and that includes the latest scientific and technical news that we have found in the Homeland Defense community. And finally, as I already mentioned, we offer a technical inquiry service with up to four free hours of technical consulting. So if you're active in the Homeland Defense community and you're interested in joining our subject matter expert community, please reach out to us directly. Our subject matter experts, such as Mark, contribute in a variety of ways, including presenting webinars, as you saw today, providing podcasts, and consulting as needed on the technical inquiries that the HDIAC receives from our user community. Again, find our contact information in the chat box on the left-hand side of the screen. And again, I want to thank all of you today for taking time out. We all recognize that time is a precious commodity. Thank you for sharing yours with us, and all our best regards and our best wishes to stay well and healthy.